Hello students, if you recall the previous lesson, you learned how to use the number line to determine opposites and compare integers and rational numbers. In today's lesson, which is lesson 7, you will be able to write, interpret, and explain the order of rational numbers in the real world using a number line. Today's lesson, which is lesson 7, you should please turn to your page S.24. Let's review a few terms before we begin today's lesson. If you recall a rational number is a number that can be represented as a fraction. For example, 1/2 is a rational number, 0.5 and 2.5. Notice the 0.5. This is a decimal, but it is also a rational number because it can be represented as a fraction. It can be represented as 1/2. Also recall the term integer. An integer is a whole number on either side of 0. In other words, integers can be positive or negative. Examples of integers are -1, 2, 5, and 5/5. Notice the 5/5. Although 5/5 is written as a fraction, it can also be written as a whole number. So therefore, 5/5 is also considered an integer. So let's review some of the real-life terms that represent negative and positive or decreasing and increasing. Some of the terms that represent negative include subtract, debit cash, withdraw funds, loss, owe, or below 0. Some of the real-world terms that represent positive or increases include add, credit, deposit cash, gain, receive, and earn. Let's begin with our exercises on page S.24. Let's look at exercise 1. Letter A says, graph the number 7 and its opposite on the number line. Graph the number 5 and its opposite on the number line. So let's begin with first graphing the number 7. So I'm going to underline number 7, and then I'm going to start at 0 to locate my number 7. So I know that number 7 is positive, so I'm going to have to move to the right until I find number 7. Next it says, graph the number 5 and its opposite on the number line. So I'm going to start at 0, and then I'm going to find 5. So let's find the opposite. So to find the opposite, you're also going to start at 0, but this time you're going to move to the left to find the opposite. So to find the opposite of 5, we're going to move 1, 2, 3, 4, 5. So that is the opposite of 5. To find the opposite of 7, you're going to also start at 0, and you're going to move to the left 1, 2, 3, 4, 5, 6, 7. And that is -7, and -7 is the opposite of 7. Alright, our next question, it says, where does 7 lie in relation to 5 on the number line? So if we look at the number line, we know that to the right of 0, our numbers are positive and they are increasing. And we know that as we go to the left, our numbers are decreasing. One thing to make clear is we use the terms increasing and decreasing. We need to understand that even if you go from left to right, on the positive side, you can still be increasing or decreasing within the positive side. For example, if we start at number 5. As you go to the right, you can see that 7 is increasing. If you go to the left from 7 to 5, that it is decreasing. So it doesn't have to be on the negative side in order to be decreasing. So let's take a look. Where does 7 lie in relation to 5 on the number line? 7 is 2 units, 2 units to the right of 5. 2 units to the right of 5. Where does the opposite of 7 lie on the number line in relation to the opposite of 5? So we're going to compare 7, the opposite of 7, which is negative 7, and the opposite of 5, which is negative 5. So I'm just going to write a note here. The opposite of 7 is negative 7, and the opposite of 5 is negative 5. So they're asking us, what is the relationship between negative 7 and negative 5? Negative 7 is 2 units to the left, 2 units left of negative 5. It is also less than negative 5. Negative 7 is less than negative 5. So let's move on to letter D. Letter D. I am thinking of 2 numbers. The first number lies to the right of the second number on a number line. What can you say about the location of their opposites? If needed, refer to your number line diagram. So let's look back at the number line here. And it says that I am thinking of 2 numbers, and the first number lies to the right of the second. So we can say the first number is 7. And the second number is 5. So let's label here. The first number is 7, and it lies to the right. And the second number is 5, which lies to the left. What can you say about the location of their opposites? If needed, refer to your number line. So basically, if we use those 2 numbers, we will end up with the same answer that we got for C. So let's use different numbers. Let's say that our first number is 2, and our second number is 1. So 2 and 1. 2 is greater than 1. And 1 is less than 2. And 2 is to the right of 1. And 1 is to the left of 2. So that's all for exercise 1. Let's move on to example 1. The record low temperatures for a town in Maine are negative 20 degrees for January and negative 19 degrees for February. Order the numbers from least to greatest. Explain how you arrived at the order. So here's a particular problem that represents real life. And in this situation, you might want to use a vertical number line since it is measuring temperature. And many times in real life, they actually use thermometers, which are vertical number lines. So let's create a vertical number line for this situation. So because it goes from negative 20 to negative 19, let's use a portion of the number line to answer this question. So if we represent positive numbers here, and we're going to use negative numbers all the way below the line. So this is 0. And this is -2, -4. We're going to count by 2's. -6, -8, -10, -12, -14, -16, -18, -20. So that means that -19 will be in here. Alright, so if this is -19 and it is above, and our positive numbers are above 0, and our negative numbers are below or decreasing, then -19 is greater than -20. So -19 is greater. So we would have -20 first, and then -19. -19 is below -20. Therefore, -19 is greater. So this is our answer. Please take some time to record the notes. Now let's move on to example 2. Example 2 says, Henry, Janet, and Clark are playing a card game. The object of the game is to finish with the most points. The scores at the end of the game are Henry, -7, Jen, 0, and Clark, -5. Who won the game? Who came in last place? And use a number line to model and explain how you arrived at your answer. So the first thing I want to do is I want to create a number line, and because we have a -7, a 0, and a -5, we want to make sure the line is large enough to include those numbers. So I've included my 0 here, which is where I'll start. And I'm going to label this -1, -2, -3, -4, -5, -6, -7, and -8. So we are marking, so it says that the scores at the end of the game are Henry, -7. So I'm going to find -7. And this is Henry. And then I'm going to find Jenna, and he's 0, and this is Jenna. And Clark is -5. So who won the game? Who won the game? What does that mean? That means who had the most points? The most points. So the most points wins. And how do we determine who had the most points? Well, we have to see which one is the greatest. So if we look at our number line, we know from 0 to the left, these are decreasing or negative numbers. So whatever number is farthest to the right is the largest number. And in this case, 0 is farthest to the right. So Janet is the winner. The next question, who came in last place? So last place is the least points. So again, we're going to see which number is the farthest to the left, because we are decreasing as we go left. And if I look at this, Henry is the farthest to the left, so he is the loser. He is last. All right. So why do we say Jenny wins? Because he has the most points, and he is to the right. And Henry is farthest to the left. That's all for our video today. Please take some time to record the notes. That's all for our lesson today. Thank you and see you next time.